Here's a little project that got sidelined for a while. You may have seen this before. These guys, these little coin counter boards from the 70's. Well, I finally got around to building the power supplies and the enclosures. So I'll do a little recap in case you didn't see the video. Meantime, this is going to be the finished product here. Numitron clocks. Alright, so in case you didn't see the first video, these are circuit boards from some device, I believe to be maybe from a coin counter or something. So these are designed to count in units of 10. But what I did was restructured or reworked the counting components in this circuit to operate as a clock. What we have here is 7400 series TTL. I'm just trying to get the lighting right, the shadow. I'm going to hold it this way. So let's start with the tubes. These are the RCA DR2100. These are the smaller Numitron tubes. You may be familiar with the 2000 series. You see the size difference. Still operate on 5 volts DC or AC for that matter, but the drivers are going to work with DC and the logic. So the 7447, these guys, this is what drives it. They're BCD to 7-segment output, and they drive the tubes directly. Here we have a string of 7490s. These are decade counters, and they count 0 to 9 and output over 4 outputs of BCD, which then gets fed to the drivers. What we had to do for this clock is, alright, your seconds is up here. That's fine, 0 to 9. But tens of seconds has to count 0 to 5. So basically you just have to take the output and jump it over to the reset, and then you can get this one to count 0 to 5. So a few traces had to be cut, a little jumper soldered on the bottom, a little point to point on the bottom of the circuit board, and that gets that to happen. So here, the next one, this one counts 0 to 9, that's your ones and minutes. And this is your tens of minutes, again 0 to 5. So we had to do the same trick with this one as we did there. Now the hours section, that gets real tricky. With the addition of a 7400, we can then get these two to work together and through some logic get your 12-hour section to count properly. That's pretty tricky. I've covered that in other videos, and I may do another video on that in the future. But this is powered by a wall transformer. I used a 9-volt AC wall transformer and brought that in through a barrel connector, and then fed that into this bridge rectifier, which conveniently is screwed to the back with a large filter cap capacitor across the DC outputs to smoothen the ripple. from there we have our regulation done with the Murata switching regulator. Okay, so it's going to bring our, we ended up about 13 to 14 volts, and this is going to step that down to 5 volts to drive the logic and the tubes. One thing I will note here, this craziness with a few diodes and a string here, that's actually to cut the tubes back a little bit, because these at 5 volts burn pretty much white hot. They're rated for that, but why not run them a little more conservative? Exponentially we can increase the life of these tubes. 3 diodes and a string here, I got them running at about 2.5 volts. What I did do, there's an extra switch on the back which jumps out one of the diodes, and that gives us a adjustable brightness setting. So we can just flick the switch, it jumps one of the diodes, and now you're up approaching the 3.5 volts or so, give or take. Pretty much covers it. As far as setting goes, I didn't label this one yet, but this is the dim bright switch I was just showing you. We have a hold button which interrupts the 60 Hertz. I'll get to that in a second. Hours section, tens of minutes, and ones of minutes, and I will label those up. Our volt transformer comes in this barrel jack here, 9 volt AC. Okay, so as far as our time base, the 60 Hertz, the hold button I mentioned, we pull a tap off of the AC coming in, and we bring that around to this side. Okay, I'm going to cover this a little quick because this gets a little interesting. I have a little circuit here with a couple resistors and a capacitor. Basically set up a little voltage divider, a capacitor to condition the incoming signal a little bit, and then that gets fed into a 7414. Alright, that's a Schmitt trigger. That's to hopefully knock out any line transients and noise and stuff and create a nice sharp square wave to then feed into 2 more 7490s, which are here. Okay, and what these do is divide the 60 Hertz down, divide by 10, and this one's set to divide by 6, and then that gets fed into the first counter in the line, drive the seconds. Alright, so one little interesting thing I'll throw in this video, and I'm just throwing this all at you. Just run it rough nowadays. Editing just takes too much effort on my part. I'm going to sit down and play with stuff. It's going to be some fun stuff. So bear with me. One thing I noticed here, the switching regulator definitely introduces a little different sort of a waveform I was looking for. There must be a little kickback or something. Let me show you what I mean. What we're going to do here is we're going to hook up the scope. I got a ground little loop tied there, and what we're going to do, here's our wall transformer, our bridge rectifier, and our unregulated output here. Alright, our Murata regulator is set up here, but for the sake of this discussion, we're going to pull AC off of this point here, feed it through this voltage divider, a 1K and a 470, and this capacitor here is key to smoothen the waveform a little bit. And then we're going to get our 60 Hertz out. This is going to be our time-based reference, and feed it into the 7414 Schmitt trigger. I do 2 in a row. This gets me 4 volts peak, which is under the max threshold that the 7414 can take. So what we're going to do is we're going to probe coming in here, and then we're going to probe in the middle, and I'll show you the signal that I'm getting, and then possibly I'll show you just a little quick square wave probing on the 7414 to show you how I conditioned the 60 Hertz to then be able to use as a time base. We're going to turn you to the scope. Alright. So we have a ground reference set at the bottom. A little intensity there. And what we're hooking up here is right off the AC tap by the rectifier. And I've used linear regulators before, and again, nothing to do with the regulator, but the switching one seems to throw some sort of a weird waveform in there, which maybe somebody can explain that to me, or one day I'll have to try and wrap my head around it. But there's definitely some weird transients here, and even over here as well. I'm going to throw the brightness up real quick for a second, and you can see them. So whatever that is, I'll have to wrap my head around that one day. But then we go through the voltage divider, bring this down to the 4 volt peak. Let's okay, so let's do a switch R. So that's a waveform that we can use, and it doesn't seem to have too much in the way of chopping or irregularities. And then we have, out of the first gate of the 714, a nice square wave. Okay, so that's a 60 Hertz square wave. That then gets fed into the two 7490's on the back of the board I was showing you. So that's pretty much the rundown. 1970's coin counter, PCB with Numitron tubes. And a pair of them. What we'll do is finish up the case, and one of them I'll keep, the other one I am not sure. I have some family that needs some clocks yet, so that's probably what we'll do. That's a wrap. I do hope you enjoyed the video. More of these clock makings to come. Have a good day. See you soon.